Hey everybody, this will be the last week. We're going to cover chapter 8 and chapter 7 this week. The assigned questions will be due at the end of the week, and then starting next week I will assign the CPT, and you'll have till June 19th, I believe it is, to work on it. Okay, so we go from chapter 8 to from chapter 6 to chapter 8. Just a couple of concepts in chapter 8 that you just need to be familiar with. You've done something similar to this before. This one's about the line of best fit. We have the independent variable, which in statistics it's called the explanatory variable, and the dependent variable, which is the response. So independent goes on the x, dependent goes on the y. You've learned this in different courses. And then something called a correlation. So positive correlations will show both x and y increasing. A negative correlation is as x increases, y will actually decrease. And we'll see what that looks like. In grade 9 math, you did linear correlations, which was y equals mx plus b. So the line of best fit, when you actually get one, we were going to do an application on the computers, but obviously this doesn't lend itself very well to that. But we were going to create these lines of best fit. And these lines of best fit had this, what was known as this linear regression. So it's basically the computer, the Excel spreadsheet comes up with the line of best fit and the equation of the line of best fit for you. Okay, so for now we're just going to classify these basic relationships. So it's positive, negative, weak, moderate, strong, or no relationship. So this is the example of a positive strong. It's going up to the right. X and Y are both increasing. And the points are tightly clustered together. That's what makes it a strong relationship. That's negative strong. This looks like a dartboard. There is no relationship. It doesn't look like it's increasing or decreasing. This one is positive. It seems to be going up. It's a moderate type of relationship versus positive weak, where they're a little bit further scattered apart. That's the differentiation point. And this would be a negative moderate. They look like they're kind of together a little bit. Okay. And the way that we can categorize the data is using something called this correlational coefficient. So it's how tight the points are clustered together. So a value of an R value, that's the letter they use for correlational coefficient, between -1 and 0 indicate a negative correlation, and then it'll have a negative slope, the line of best fit. If it's between 0 and +1, it's a positive correlation with a positive slope. A value of 0 and our value of 0 indicates that there's no correlation at all. There's nothing tying the two together. Okay, and we have this kind of sliding scale, and you can take a look at that. Okay, so a couple of questions, 390, 1, 3, 5, and 6 for 8.1. We'll go on to 8.2. So this one is, again, some theoretical stuff. This is called cause and effect. So relationships either cause one another or have something else kind of going on. So if there is a strong correlation, it doesn't prove that there is a cause and effect relationship. There can be other explanations. Okay, so the typical one is a cause and effect relationship. So as X goes on, it'll produce a change in Y. So an example of this: on a clear sunny day, you're going to get more sunburn the longer you stay in the sun. Okay, so X being the amount of time you spend in the sun, Y would be how sunburnt you are on a scale of 1 to 10, or whatever the case may be. Okay, there could be something called a reverse cause and effect relationship. So the dependent and independent variables are reversed in what's responsible. So there is a positive correlation between the amount of coffee consumed by adults and their levels of anxiety. So as you drink more coffee, your anxiety level goes up in this study. Therefore, drinking coffee causes anxiety. Or you could also view the reverse. Nervous people, people with anxiety, tend to drink more coffee. So this can be a reverse cause and effect relationship, where it might not be the initial thing that you see causing one or the other. It could be the reverse of it. Okay, an accidental relationship is a correlation exists. So there is some kind of trend, there's some kind of pattern, but it doesn't have any causal relationship. So positive linear correlation between the number of females studying science and the number of game shows on TV. Nothing to do with each other, but if you were to graph them for whatever reason, they might show some sort of relationship. So that could be accidental. Presumed is a correlation does not seem to be accidental, even though there's no specific cause and effect relationship. And this other thing doesn't exist, which we'll talk about in a second. So a presumed relationship is there's a positive correlation between a person's fitness level and the number of adventure movies they watch. Okay, so one doesn't cause the other. Being fit doesn't cause you to watch adventure movies. Adventure movies doesn't cause you to be fit, but they have a presumed relationship in the fact that maybe the person is an adrenaline junkie, for instance. So that's kind of the underlying situation, and we just assume that maybe that's what's going on in that case. Common cause, an external extraneous variable causes two variables to change in the same way. So a graph of ice cream sales versus tomato harvest during the summer has a correlation. The common cause factor being the weather. So the better the weather, the more ice cream sales, the better the tomatoes grow, whatever. Okay, so it's a common cause relationship. So we're going to just try to identify the type of relationship. In these scenarios, if you can sometimes argue more than one, but these are the ones that seem to be the ones that are most correct, that type of situation. So the number of fire stations in a city is positively correlated with the number of parks. So I put down this as a common cause. The common cause of this is the population of the town. So taxpayers, money, dollars, build fire stations, build parks at the same time. So they're positively correlated. They have that relationship, and it would be based on the size of the population. Price of butter is correlated with fish population. That would be accidental. They don't really have anything in common. They just have this accidental relationship. Seatbelt infractions are positively correlated with traffic fatalities. So it's not the seatbelt infractions that are causing the traffic fatalities to go up. It's actually the reverse. The traffic fatalities, if you're in Caledon and you see that there's a lot of people with traffic fatalities, you're going to go out there and you're going to give more seatbelt infractions. You're going to put your police officers out there to remind people to wear their seatbelts and be safe. Okay, so this is one of those ones. It's the reverse. Self-esteem is positively correlated with vocabulary level. This would be a presumed relationship. It doesn't necessarily mean that self-esteem causes your vocabulary to be high, but if you're well-spoken, if you have a good vocabulary, your self-esteem potentially might be a little bit better. You can carry yourself in a conversation. You're not anxious when you go out to talk to people, whatever the case may be. So this is a presumed relationship. And charged crimes is positively correlated with the size of the police force. So if you have 100 police officers, there's going to be a certain number of crimes charged. If you double it to 200, you're going to have more crimes charged. So this one is the straight cause and effect relationship. Okay, so try that, 399, 1 to 9. And that's it for chapter 8. Okay, if you have any questions, I'll be online. Have a good day.